Okay, so let's wait for others to join. We will start sharp at 12. So let's begin. A very good afternoon to everyone. Welcome to Kaggle Days Meetup, Delhi NCR. We are here with our 15th meetup, and Kaggle Days Meetups are a series of events all over the world that aim to gather Kagglers and people interested in data science, machine learning, AI around one city. So today we have Sandip, Bhattacharjee, and Shahul as our guest speakers talking about their experience. Sandeep sir have 13 years plus experience in data science field and he currently works as VP and Chief Data Scientist of TabSquare.ai. Also, he is a Kaggle Forex expert in top 1%. And we have with us Sahul sir. He have lots of hands-on experience in data analytics and also data science field and he's Kaggle Notebooks master and also Kaggle competition and discussion expert among top 20. So today we will be having a hands-on session on large-scale recommender systems and sentiment analysis from beginner to pro. I hope this session will help and will be informative and interactive for all of us. Moving to our agenda, from 12:05 to 12:45, Sandeep sir will talk about large-scale recommendation systems and the tips and tricks. After that, there will be a Q&A session till 1 p.m. And then from 1:45, Sahul sir will talk about sentiment analysis from beginner to pro level and also a brief introduction to an AutoML open source project. All of you can send your questions and queries regarding the talk in the live chat or comment section. The speakers will try to answer them during the Q&A time period allotted or scheduled. So, guys, thank you for joining in. And this was all about the beginning of our session. So, I request Sandeep sir.
All right. Thank you, Kaggle Days Delhi NCR team, for inviting me. I really appreciate the gesture. It's been a while since I have done any talks in Kaggle Days, so really happy to be here. So let me share my screen. We'll start off with a very small presentation to talk through, and after that, we'll make our way through to doing actual live hands-on session. So let me share my screen. Let me know when you guys can see the screen. Okay, so
Yes, sir, it's visible now.
okay, let's get started. So very briefly about me, I mean, thanks for introducing me. I just wanted to highlight one or two things regarding to the session, which will make it relevant. So like uh, all of us here, I am a Kaggler. So I joined Kaggle almost 5 years back, but like many of you people, I used to sit in the sidelines for almost first 2.5 to 3 years. So I've been active only since last 2.5 years, and that's where I try and do competition when and when my time allows. So yeah, you can say that I'm a part-time Kaggler. In terms of my practical experience with recommender system, I've been doing quite a bit, so which will probably make it relevant. So in my current work and my previous work have done a lot of implementation. So some examples like we did an industrial parts manufacturing recommending system, which covered more than 150,000 items. We built two large-scale recommender systems for a large American QSR chain, which has more than 2,000 plus outlets. So one of them was for their online ordering, which was serving 1,500 plus items to more than 20 million plus customers on a day-to-day basis. One was for a one-to-one offer personalization for a loyalty customer base in the north of 10 million plus customers. Have been doing some work around financial education content recommendation as well. So for this particular client, I did work where they had in excess of 1,800 plus items. And my current experience in TabSquare.ai, it's just about personalization for leading F&B brands in Southeast Asia. So that's where my majority of the time goes. Now, before we get started for today's discussion, I quickly wanted to go through what all we'll cover today. So first is a very brief introduction about what recommender systems are, where do we see them in everyday life. Secondly, types of recommender systems. So I will limit it to very high level overview because the focus of today's session will be a live demo. That's where we want to spend most of the time. We'll briefly talk about what is a large scale recommender system, practical tips and tricks for which would be very useful for you guys to train your models, evaluate your models, deploy your models. And finally, the hands-on session. So for any of the participants who want to follow along live, obviously one of the key criteria would be that you need to have an active Kaggle ID. So I'll post the link to two notebooks which I've created specifically for this session in the last couple of days. So anyone who has a live Kaggle ID can actually fork the notebook and essentially follow along. Other than that, obviously basic knowledge of Python data structures would be needed along with some basic knowledge of sklearn for pre-processing and test train split. Now, just like we talked about things that we will cover today, I quickly wanted to talk about things that we won't cover today so that we are clear in terms of expectations. So one is obviously the derivation of the mathematical equation powering these ML systems because each of these systems are like really advanced system with decades of academic research behind them. So we won't be covering any uh, part specific to how these equations are derived. Similarly, we won't be doing an actual demo of how to deploy a live recommendation system on cloud. Maybe that's a topic for a separate meetup. So typically the end use case is when you have built a recommender system, you would be doing it for any commercial system. So deploying on the cloud and all, we won't be doing it. Thirdly, the session will not cover basics of Python data structure because like I said in the previous slide that this is one of the prerequisite or general syntax. So for the purpose of the demo, uh, this has been kept simple enough so that there are no complex user-defined function or user-defined classes just to make sure that everyone is able to follow. Right now, when we talk about recommender systems, the first question that comes to mind, okay, what are recommendation systems and what's the hype about it? Right now, very technically speaking, recommender systems are systems that are able to analyze a user's behavior, the similarity in behavior, similarity in the item or feature attributes, overlap and probably overlay other factors that affect a user's behavior and use all of them or maybe some of them to essentially come back with product recommendation, content recommendation, or services recommendation that are highly relevant for the user, right? So now, where do we see recommendation system? Actually, recommendation systems are actually in today's age, they are everywhere around us. So be it a video content platform like Netflix or YouTube or Amazon Prime, it's there. Whether when you go to order your food, it's there. When you are streaming movies live or songs live, it is there. When you go for your online shopping, it is there. Even when you open your day-to-day social media things like Facebook, LinkedIn, Instagram, the stories you see, it's there. When you open your Google News feed, it's there, right? So recommender systems are probably one of the most successful and widely used commercial applications of ML, right? So the crux of the matter is, yes, recommender system in today's digital age is everywhere. Now, when we talk about recommender systems, there are broadly speaking, there are three types of recommender systems which you would see in practice, right? And the way these things work is they analyze historical interactions, similarity of user attributes, and combine them in various different forms and manner. So the first two ones which you see here are the most common ones which you would see in your day-to-day, let's say, tutorials on various open source platforms, and also content-based methods, collaborative filtering, and then most commercial applications that go online, they are mostly hybrid methods these days, mainly because they generally tend to outperform any single method that we have seen here. So what we'll do in the next couple of slides is quickly go through very high level overview of each of these. Again, not going into too much detail about theory, and then we'll move to tips and tricks, and after that go to the actual session. Right. So the very first one we'll go through is the content-based recommender system. Right. So here, as you would know, and you might have seen in many tutorial, it's about item features, and you essentially want to look in similarity for these item features and then recommend items which are similar to an item which a user has previously interacted with or used, right? So let's take a real world example, right? So say, for example, the App Store on Google or Apple iOS, right? So uh, you have a lot of, let's say, uh, items there, right? And say if you want to build a recommender systems. So if you were to use a content-based system here, you would essentially want to represent, let's say, your items here in the rows. So here in this diagram, each row essentially represents an app, right? So some app could be because of health, some app maybe is a game, maybe is an educational app, and so on and so forth. And the columns here are representing the feature or attributes, right? So we basically describe each of the attributes that define this particular uh, app for our use case. Now, how do we come to a case from where we can essentially go back and recommend useful apps to the end user? So the trick is you essentially need to represent the user in the same feature space, right? And this is typically done in the form of some past explicit behavior that the user has shown towards certain apps. And this could be in the form of maybe download and keeping the app live on the mobile for a certain cutoff duration, or maybe giving explicit rating on the app store and things of that nature, right? And once you have represented that, what we end up doing is we choose any sort of similarity metric. So again, for example, a similarity metric could be as simple as a cosine similarity, right? And what we do is, this is an n-dimensional space where all of the items are, and some of whose interactions are there with the users are represented. And what we are trying to do is we are trying to find out the cosine of the angle between any two item pairs. And as we would know from secondary school math, that cos of 0 is 1, which essentially means if you look at this particular diagram, once as the angle between the two lines closest to 0, they are becoming more and more closer to each other in the vector space. And that essentially means in the context of this, that their attributes are very much similar, and hence if a user has used item 1, then you would go ahead and essentially recommend item 2 or item 3 which are similar. Right now, let's quickly move to collaborative filtering based system. Uh, many applications or commercial applications actually use this, and because they are much more scalable than some of the content based method also, although there are ways to scale those method as well. So, but the essence of any collaborative filtering based system is that it pivots around finding similarity between users and items simultaneously. And Since you are able to find out a similarity in users, you are essentially able to recommend an item to a user which is based on similar feedback from other users, right? And you might have seen this happen is that sometimes when you open your YouTube feed, you might see that okay, you got a recommendation which you didn't think was could be useful, but when you actually saw, you found it useful, and that is because of the latent similarity which these systems are able to find out. Now, in terms of types of collaborative filtering based system, there are lots. For the purpose of this session and to keep it brief, we'll probably quickly discuss the two most commonly used systems, right? So the first one is about user-based k nearest neighbors. So again, the essence of that is you represents each user in terms of their interactions with the entire universe of items you have at hand, right? So if you, in this case, let's say if you represent them for simplicity in a 2D space, you see all of these blocks of different colors and round shape. These are all, let's say, users. Now, today, if you have to recommend certain items to, let's say, user W, which is given by the blue colored flag at the center, you would essentially try and find out the distance of this particular user in the n-dimensional space from each of these different users. And in this example, you would see that okay, it so appears that it is much more closer to the user group given by X. Hence, you can go ahead and start recommending similar items or contents which the users of X group has been seeing. So that is about user-based k nearest neighbor. Now, the one which is most often used in industrial applications is matrix factorization. And incidentally, we'll also have a demo of this. So the essence of this is, again, in any real world application, you do have cases where you have large number of users and large number of items, and you won't get any explicit rating or feedback for all of the user item combinations. So what happens is that you end up with a user item matrix, which is highly sparse. And what matrix factorization does is it's a shortcut way where you want to decompose this single matrix into two smaller matrix. And the dimension of these matrix is essentially a sort of a hyperparameter which you have to tune based on the use case you have at hand. But once you have done the decomposition into two small matrices, one which is about representing the embeddings of users, second is about representing the embeddings of items. The dot product of that is essentially trying to replicate the same user item matrix from where it started. And what ends up happening doing that is you essentially are able to recreate some of the missing user item ratings, which in this particular diagram are shown in the form of yellow boxes in the left-hand matrix. And again, many commercial applications do end up using this. So finally, moving on to hybrid recommender systems. So again, like the name suggests, this is a hybrid method where you can use both collaborative filtering content-based system, and as well as in many cases, users would also, or the companies would also overlay some business rules and heuristics to essentially, which are catered to their specific business needs. So on one hand, you will have inputs which could be explicit feedback, implicit feedback. Other features could be things like seasonality, maybe other factors which drive the demand. Run through these uh, recommender systems on their own, and then you essentially would have to build any bespoke output ensembling. Now, this again, as I keep on stressing that the way you ensemble has to be driven both by data science as well as the business requirement at hand. And using that, you'll finally be able to go ahead and recommend the systems. Now, before we dive into tips and tricks, one may ask that What is a large scale recommender system? Right now, the answer to that, I mean, there's not a very black and white answer to this. It's a function of two things. So one is the number or types of items or contents that you have in your portfolio that you want to pass out through the recommender system. Second is the size of audience who would be the consumers of these recommender systems. Now, typically any large recommender system can recommend hundreds of items and probably serve thousands of customers, right? And if you go to real world examples like YouTube, it is actually serving billions of customers with video categories ranging across probably into millions. So that's a massively large recommender system. Now, with all of that background, let's quickly move to practical tips and tricks, right? So, very first practical tip that you should know while building any commercial grade recommender system is you are bound to see very less of explicit feedback and more of implicit feedback. So, by that, what I mean, any online tutorial that you would see or any online resources that those are showing for simplistic cases, you would see that they talk about the concept of rating. This is an essentially a sort of explicit feedback that the user has given to say that, hey, I like this, I don't like it, maybe this was very okay types, right? And the reason for that is in majority of the cases, we as users are quite lazy. We never bother to provide rating. I mean, I specifically, when I watch Netflix, it's very rare that I would go ahead and provide rating for any movie title. Right now, how do we go ahead and build a very large recommender system in that case? So the trick towards that is based on the business case at hand. You can essentially use implicit feedback to create some sort of a proxy for explicit feedback, right? So maybe give you an example. So again, coming back to a case of a video recommendation platform, let's assume that this is a video recommendation platform where there are only hardly 10% or less people who provide ratings, right? So where one very simple workaround could be that you essentially could use percentage of viewed time as a proxy to create some sort of rating. So by that, what I mean that, okay, for each video title, you essentially look at the total length of the video and then say that, okay, let's say if it is 0 to 20% and the user has never come back to see it, then it means that he didn't like it, he or she didn't like it. So in that case, it's the rating could be 1. 20 to 40% they have not come back could be 2. 40 to 60% maybe 3. 60 to 80% maybe they've done multiple viewing, shows that they have some amount of interest, and obviously greater than 80% which they have ended up finishing or did a bulk of it, maybe went all the way through to the credit scene or just before the credit scene, mean that there was a lot of interest, right? And that way, once you have that, you can essentially you have some sort of an explicit feedback and you can go ahead and start maybe experimenting with the explicit feedback system to see and create some sort of a baseline uh, system first. Now, second is the question how to create train validation split while training a large scale recommender system. Now, this might seem like a very trivial question because, hey, one might say, hey, it's a machine learning system, so let's go ahead and do our usual k-fold training. K can be a fraction between 0 and 1 and go ahead and do this. And that's what you would do to any straightforward machine learning system. Now, what we need to understand is what this particular machine learning system is trying to do. What we are trying to do here in most use cases, it is that you are trying to predict a set of user behavior given a set of past behavior. So take for an example, let's say if this was an e-commerce system where you are trying to recommend order cart level recommendation, right? So at that point, it could be a case that, okay, maybe the user has 2 items in the cart and you want them to probably fill out 2 or 3 more, right? So in that case, you would want to essentially test the recommender system for its ability to complete this incomplete order cart. So what we do here is a little bit different, and take a note of this, right? So the upper box here is your usual training set where you would pass all the users that are there and all the items. Now the lower left hand box, which has the 1 minus k fraction of the total users, right? Here you would also hold out a j fraction of total items, and your training model gets the upper larger box, which is light blue in color, as well as the lower box, which has got a part of all the test users, but these test users only bring in a part of the items which they have interacted with. And your validation set here in this case is essentially 1 minus j fraction of total items for this 1 minus k fraction of total users. And understand that even in this set, this set wouldn't be fully symmetric. So for some users, you may have held out 10 items, and these would be cases for users who have very large order cards. And for some users, you may have held out just one item, right? So this is a very crucial thing to understand before understanding how do you actually go ahead and evaluate a recommender system. So this is one very practical tip which I have found very useful to know whether my recommender systems would work in real life or not. Now coming to how do we evaluate the practical performance of a recommender system. Right now there are two parts to it. One is called analytical measures. Second would be business measures. So analytical measures would be where I mean when you're building a recommender system, in most of the literature you might have encountered people saying, okay, let's use root mean square error, right? So root mean square error is fairly simple. All of us know you essentially compare the predicted ratings against the actual ratings. Now, in many real world applications, root mean square error is actually not that good estimator of a real world performance. And the choice of an analytical measure again kind of depends on the actual use case you have in mind, right? So let's take the case of grocery e-commerce uh, uh, recommender system, right? So maybe something like an Amazon pantry or maybe a big basket, right? So what the grocery recommender system is, it is trying to do and sell you additional item based on your current order card, right? So in that case, your evaluation criteria should check your system's ability to replicate the remaining item choice to make the order card complete for your actual end user, right? So in that case, since it's a grocery retailer, your actual order of recommendations doesn't matter. So in that case, you would typically be looking at, let's say, overlap of your recommendations with what the recommendations you had held out from your actual validation set. So here you could use things like precision at top n, recall at top n, and then similarly think of a very different use case, that what about the recommender system which is helping the customer start its journey. So right at the login where they have not even put in even a single item, right? So in that case, the ranking becomes important. So here you should look at things like normalized discounted cumulative gain, mean reciprocal rank, right? Then again, let's take just one more example before we wrap up this piece. So again, let's say it's an online content recommender system like Netflix or YouTube, right? So one has to also take care of things like freshness and diversity of recommendations, because if your recommendations become stale in this particular use case, if you keep on recommending same video titles, you are going to lose customers, right? So you should also look at in addition to things like NDCG, you should also look at percentage of repeat recommendations or percentage of categories which have never been recommended, right? So that's in terms of analytical measures. Now let's move quickly to business performance measure. Now, why do we need business performance measure? The simple reason is that yes, you may be proud of the recommender system you have built. Maybe it has done exceptionally well in the test you did. Maybe it has got very good in all of these measures. But if it's not able to sustain the business case in mind, then it won't be useful. So in that case, typically we look at short-term metrics as well as long-term metrics, right? So short-term metrics would be uh, things where it helps you take faster decisions. So you could look at things like percentage of accepted recommendations per API call. For media content, you may look at simple things like number of hours streamed per user, click-through rate as well, although in some cases it can mean that your recommendation is not doing well because it may be asking people to look at other places, and you may also look at bounce rates for the particular recommendation page. Now, in terms of long-term metrics, the overall metric is obviously to see how it is helping the business sustain. So we typically look at things like lifetime value of customers and customer retention and customer churn, right? And let's move to this one final practical tip before we go to this thing. So in this case, I will show you a very realistic scenario, and we'll see what happened here, right? So again, this will be through an example. So suppose it's a Singapore-based e-commerce company. They've got very good, highly trained hybrid models deployed on the cloud. So their e-commerce customers come in, they start shopping, and based on that, the system makes an API call for serving recommendations. Recommendations are served. Customer exits without accepting the recommendation served. Now, what just happened here, right? So say we did all of the things that we discussed previously, but it still didn't work out. So let's look at this thing with a little bit more detail, which will help you understand what we are trying to do. So again, let's go through the same thing, but see the difference here. The trained cloud model on the cloud has been deployed in the region US. So when the e-commerce customers comes in and they start shopping, API call for serving recommendation is done. The latency to serve the model from the region in Singapore is actually uh, taking 500 milliseconds. Now, most of the commercial grade recommender system, they would have a certain latency SLA, right? So in our case, we typically have a 200 millisecond SLA, and if the API response is taking this long, you won't want a scenario where customer sees a blank page. So what we typically do is you have a backup static recommendation to at least not hamper the customer experience in general. And what's the risk of that? The static recommendation just may not be relevant, right? So, I mean, the moral of the story is that make sure that once you have built a very highly accurate recommendation system, your cloud services region is either the same or as near as possible to reduce the chances of API timeout due to increased latency. Okay, now finally hands-on session. So for this, we'll be using Kaggle resources. Let me stop sharing. Let me ping the link of the first notebook that we'll be using for this. So, so the organizers, if you could
Okay,
share
so
the,
you just share up the links. We will
yeah. So let me
put up,
share
put them
my,
up in the comment section.
yeah. Let me share my screen again. Just give me one moment. Okay. So now for today's session, hands-on session, we will look at two systems. One would be to create a matrix factorization system using three different methods. And we'll also quickly look through one hybrid method called factorization machine. So if you guys can see the screen, let me start by just forking my own notebook. If any of you are here and you are on Kaggle, you can probably do the same. This does use the GPU, right? And the Kaggle resource that we are using is called Goodreads book datasets, which has both book data as well as user ratings, right? So in this case, we will be demoing basically three methods of doing matrix factorization, which is your collaborative filtering. So the very first method, okay, the session has started. So right now, this one is fairly self-explanatory. We are importing all the stuff, right? Let's quickly import all the files. You can see my screen here. This has a lot of book related data. So this will have metadata about book. You will have user rating, so on and so forth, right? So right now the cell I'm running is just importing all of that. So we see that right now this has, and again, just a quick disclaimer. This notebook was put in in a very hurried manner. So the results may vary because I've not seeded everything. But there are two tables. One is book rating and the second is user rating. Let's quickly take a look at book rating. So here you can see you have name of authors, name of books, ISBN, average rating, published year, published month, number of ratings for 5, 4, 3, 2, counts of review. You would see there are some blank things as well, right? And some description as well. The other data frame is user frame rating. So this is a mix of people who have not rated anything as well as people who have rated. So here, like you see, the first rows are cases where there is nothing. So if you quickly change it to something else, yes, you'll see here that these are IDs of customers who have read or seen this book and they have rated it, right? So right now there are about 5 distinct ratings, right? So there are about 968 unique users here, right? So let's quickly convert all of these into a scale of 0 to 5. Right now I'll use learn pre-processing. Once we do it, we see that, okay, yes, looks good. Now, since this is a collaborative filtering and specifically matrix factorization, right now this brings into question something known as a cold start problem, which I didn't say in my this earlier. So one of the limitations of a collaborative filtering system is if you have cases where there are no previous history or interactions, it cannot work, right? So there are other ways to handle it. Typically, people in practical applications would go ahead and essentially do maybe allow the recommendation system to gather some data over time, or maybe for the first few days use some heuristics, right? So in our case, we are probably removing all of those. Let's look at the number of ratings by customers. So it seems that there is a very long tail, but bulk of customers seem to be giving at least 5 ratings or more. So let's quickly see. Yes, so it seems that percentage of people with 5 or more reviews is 77 or more. Right, so we'll quickly now, based on how I had explained, we'll split our train and test. These sets are essentially doing the same. I'll probably not go there. Right. So once we have done this, this is how our user rating train dataset looks. Now, for doing singular value decomposition, your matrix needs to be in a wide format, right? And right now it's in a long format, right? So here we see that, okay, these are 470 users, right? And we have got 21,779 unique books. So at least it qualifies as a large scale recommenders, although the your real use case would be much larger, and probably it's good for us so that we can do a very quick iteration of this. So by doing SVD, what I'm doing is essentially I am breaking down this entire matrix into three component matrix, right? So one would be U for user, right? And then we would have one for books, and then we would have a diagonal matrix called sigma, right? Let's quickly do a pivot here, and we have filled out any missings with zeros, right? So you see a lot of columns here. Let's do some normalization of scores. And again, for a very quick thing, I'm using the number of or the size of these little matrices k as 100. For your cases, you can play around with this value. This is a hyperparameter and see which one works best. And once we run through this, okay, so we have generated our uh, ratings. Now, remember, this is a book recommendation case. So in actual practical applications, you would be not just showing one book, but a collection of book, maybe 8 to 12 on the UI. So typically, again, we would probably look at, uh, let's look at a case. Okay, let's probably, okay, I didn't put the image here. We'll come back to here. Let's look at the percentage overlap for this system, right? So percentage overlap, this is a very simple uh, user-defined function which we are just checking the from the test set. Now what we are seeing here is that, okay, it's not that bad. Effectively, we are able to recommend 2 out of 4 correctly, right? So let's see, can we make it a bit better? So one of the most frequently used algorithm for matrix factorization is also known as an alternating least squares, right? So what an alternating least square does is essentially break down this into two matrix in a similar way, but the way it actually uh, does this is a bit different. So it's an iterative way where, let's say, it will first randomly initialize the user matrix and then try to optimize the book matrix. Once it gets the first version of book matrix, taking that as fixed, it will try and optimize the user matrix, so on and so forth, for a certain number of iterations. Right. So again, the book you can review and all of these comments at a later stage. But for this, we'll be using PySpark, right? So because in my applications, we have used Spark, but for the purpose of using Kaggle demo, I found that we can easily install PySpark here. So let's wait for PySpark. The Spark has a very good implementation of ALS, which makes it really nice and scalable. So if you're actually using Spark, you can use the library called mlib, which helps you gain like do parallelization as well. So a lot of good benefits. It's a very stable library, maintained very frequently, and from my experience, many of the uh, production grade recommender system do use it. So just give it maybe 1 more minute to install all of these things. I know we are probably 3 minutes uh, near to the Q&A session, but almost there. It's building the wheel for PySpark. And the next session, next cell, you would see I'm importing things which are required to deal with data frames and all. And the library for PySpark is pyspark.ml.recommendation. So you import ALS from there. And let's quickly do this. So now I'm setting the Spark context to initialize Spark. Context, let's do it. Now, one caveat is that for you to use ALS and Spark, both the customer IDs and the book IDs need to be integers. We convert them into that. Let's do it. Okay. I'm just going to just write it to a temporary file and re-ingest it in Spark. So now you see that this is how the Spark data frame looks. You have user ID, book ID, and rating numeric. Now here the rank is a hyperparameter. Max iterations is a hyperparameter. For keeping it short, run this, right? Let it run through. So here this will be breaking it down into, so the user matrix will essentially have 20 columns, That's what the rank does. Let's quickly look how it looks. Here you see for the user 3180, these are the latent features for the user. These are the embeddings, right? Now let's do a quick prediction and check how the predictions look. I'll also show you why root mean square error is not a very good thing. Here you would see if you just look at root mean square error, this probably won't come out very nice. Right, let's look at the root mean square error here. While we are waiting for this, organizers, is it okay if we go overboard by just by 5 minutes?
Yeah, sure, sir.
Okay, right. So here you see that the root mean square error is 1.9. Now let's quickly check the overlap with the actual predictions. Now you see it's a very large improvement from where we started. So on an average, it's like 3 out of 4 books are now getting recommended correctly. Now let's quickly do the same thing using a deep neural network, right? So before we jump into that, I quickly wanted to explain the main fundamental thing which we'll do to basically mimic the matrix factorization, and this is by in Keras we are using the embedding layer. Right now, this embedding layer is something which you might have used in your NLP thing, which is good for sequences, but I mean it is not the case that you can just use it for this, right? So let's quickly look what it is doing and why it is important here, right? So here I've done nothing. It's essentially a very basic neural network, which is an embedding layer. The input is a vector of size 2, right? And these two inputs are integers where were expected to be in from the value 0 to 9, right? So you would see that the total number of parameters is 40 because output dimension is 4, right? So what is happening? Let's quickly take a look here. So if I query the numbers 1 and 2, I get this vector. Now what is happening is it's more like a very basic lookup table, right? So by that, what I mean is if you just say embedding layers get weight, you see that this 1 and 2, these two rows here, they're exactly similar to what you get here, right? So these weights are nothing but randomly initialized weights, which Keras is doing, and we are essentially pulling them. Now what happens is that I'm going to use this embedding layers to essentially randomly generate embeddings for both users and books. Then I'll be using the dot product, and essentially our network is going to learn to essentially optimize these embeddings to try and replicate the user ratings. So just for the sake of clarity, I'm re-importing this since we did a lot of transformations. Wanted to keep it clean. Okay, let's do some basic pre-processing. Okay, we do a test train split. For you, anyone users, you could go ahead and do a k-fold as well. Now, if you see here, I'm using the user embeddings here, right? And the number of latent factor is something we can play around with. This is what will decide how good or bad the network is, right? And similarly, I have a book embedding here, and then finally I'm combining them using a dot product, and then essentially the network is going to learn and optimize these em- embeddings here, right? So let's quickly build our model. See that almost 1.7 million parameters to estimate. We'll do just 5 epochs, batch size of 128. Again, the loss is mean square error here. So almost there. Okay, let's look at the So it looks like our training, the model has actually not overfitting a lot because both the losses are met quite nicely here, right? So let's look at the same metrics again. Okay, let's do this. Generating the same overlaps. Looks like using this without any hyperparameter tuning, we were even able to match the performance of the ALS algorithm which was done on Spark. Right, so now all of you who are forking this notebook, feel free to play around with this. And again, I'll try and update this notebook to make it much more reproducible. But I'm going to close this notebook because I wanted to quickly go through one more version, which is about uh, an hybrid system. So remember the case that we had a lot of book metadata there which we couldn't use using a matrix factorization. So wouldn't it be nice if we had a system which could essentially use not only the benefits of matrix factorization but also use this exogenous data that we have here, right? So that is where the case of matrix factorization comes in, right? And sorry, factorization machines come in. These combine the flexibility of matrix factorization as well as you can bring in a lot of additional data here. Right now, this is based on an original paper on matrix factorization, and my code here is inspired by the LightFM library. So I'm trying to recreate it. It's been put in very hurriedly. I mean, the main, I mean, there is a lot of work needed around writing specific uh, mm, loss functions which help it for use cases like learning to rank. But just to illustrate the use case of how it's being done, uh, I'll just quickly run through this. Since we have done most of the things, I'm going to rush through these items one by one. Right, so let's quickly pre-process some of these data which we can use. Right, I've created some numerical features here which we'll try and take into the network. Doing some min-max scaling for these additional pieces. I mean, anyone can feel free to do other forms of scaling or see how it works, right? This is where we are creating book IDs. Let's quickly run through these. Now, we already talked about the use of the embedding layer. So the only additional piece that I am doing, which I'm going to skip through these here, is highlight the exogenous features here. So see that the features that I got in additionally, I'm also putting them in the network. And what I'm doing here is in this layer where I'm taking the previous case, which was trying to replicate the matrix factorization, and I'm also adding uh, that layer along with this exogenous feature. So the network will try and optimize the ratings based on these two things. Let's quickly run through this. So this, you would see there are a couple of additional parameters here which need to be estimated. So exogenous embedding that we got for the inputs, there are about 180 parameters. So little additional parameters here. This will need probably additional epochs. Let's give it a couple of minutes, 1 or 2 minutes to run through.
Sir, in the meantime, you can take the questions. There are a few
Yeah,
questions from our attendees.
Okay.
Yeah, I will just show it the below
Yeah,
the
let me
screen. I
stop
will just
sharing.
show.
Yeah, let me stop sharing. Yeah. Okay. So what are the questions?
Yes, sir. So
Right.
the first
Okay.
question is from like for a CPG manufacturer, how well can the hybrid recommender system work for physical stores assortment planning? Can we create recommendation without having transaction level data?
Right. So very good and I would say innovative question here. Right. So technically speaking, assortment is something which is a case where you are trying to find out which items or which SKUs to place in the front rows, right? So yes, that's a use case, and definitely one could do that, right? But the only thing that you need to do here is, unlike any online case where you can actually serve it for one user, one type of setting versus a second user or different type of setting. For a physical store, you cannot do that. So whatever you show, it will be static for all of those particular users that come in, right? So in that case, I don't think this will work out nicely, because if you have say 10,000 customers coming in, everyone gets to see the same thing. However, if you think from an e-commerce side of a CPG manufacturer, yes, you could do it. Now, having transaction level data, I mean, if you don't have transaction level data, you could go ahead and think of some other things, that maybe you could do a proxy, like for a CPG use case, look at the number of facings that were quickly picked up, right? Because those would be the actual explicit feedback that the user have said there. So what I mean by saying that is, at the start of the day, you would know that, okay, what were the number of facings I had for each of the SKUs. At the end of the day, you look at it, whichever went missing are the ones which the users have done, and essentially that is your explicit feedback. You can mm, then use it to create a recommendation system. But I would suggest you to evaluate it in the perspective that it's a modified use case. It's not for personalization, but certainly you could do it. Okay, let me quickly show the results which have come back. So as we can see here, uh, it didn't do that well in terms of losses. Yeah, but the spread of the ratings is quite nice. Right, let's quickly look at the overlap that it was able to generate. And like you see that this is even a massive improvement from where we started in matrix factorization, right? So definitely this could be further improved if you have user features as well, which are not built in here. So I'll stop the hands-on session here. I will stop sharing the screen and essentially take any further questions. And yes, if any of you have liked the work, please do a vote. Okay.
Sure, sir.
Second question is, if
Yes,
a
sir.
data.
There are many questions from our audience,
Yeah.
and like the second one,
Let's.
I guess you will be able to see on the
Yeah, I can see
screen.
the screen. Yeah, let me
Yeah.
read through it. So question is from Shivam. He asked that if for a data set where there is no past history available by user, that is content-based system, is content-based system the best way to go forward, or a hybrid recommendation system after information collected by the user? So from a practical perspective, Shivam, what I have personally used is, we have used a hybrid system where, like I was saying, we essentially also overlay heuristics on top of that. So let me give you an example, right? So for an e-commerce case, if it's a very new user and for whom we have got no data, and if they are just browsing through the pages, right? What we sometimes do is just use their browsing data to create similarity with other users and serve it. So, and the initial recommendations can be served based on that. Sometimes you could also look at, if you have things like demographic or certain regional references coming through a certain set of items, maybe you could go ahead and do that as well. And yes, in some cases you could do content-based system as well. So the short answer would be that there's not one way to solve it. I keep stressing that it's a function of the business problem you have in mind, what is the product you are trying to sell, and see if you can get additional data in any form or manner.
And sir, other thing to add, like in this scenario, what would be a good validation method for a content-based system? Like if, as discussed in the last
Mhm.
question,
Right.
what would be a good validation method
Yep.
according to you?
I think validation system, the validation method again will depend on what your product is, what is the use case, right? So again, if it's an e-commerce scenario where you are in the first stages of the consumer journey, where you want to get them start to buy something, then obviously your you would need to first look at that while training, whether your training system is able to uh, uh, get the ranking right. And in the business scenario, you would have to gather data and see the percentage of accepted recommendations for this new user. Whereas if your use case is you are trying to cross sell or upsell an item, in that case you may look at again something like percentage of accepted things. You may look at, okay, what was the increase in average bill value, things of that nature. So everything has to be tied to the kind of monetary benefit you are able to generate or the increase in engagement you are able to generate.
Okay, so like seeing up the schedule time. So there, if there are many any other like the doubts and queries from our like audience, I will share you up the questions side by side. And thank you so for the wonderful and code heavy session. So I really hope our audience enjoyed it and learned to build a pseudo Netflix of their own.
Yeah,
And
and just one thing before we close out, I think I forgot
sure,
to
sir.
give the link of the second notebook, which is about factorization machines. Can you share it in the audience?
Sure, sir. Sure, sir. We will put this up.
Yeah, all right. I think that was a miss on my part, but I really enjoyed interacting with the Kaggle Days community. I personally like the community a lot. It has helped me grow as a professional, and I hope some of you found the session useful. And I'm looking forward to the next session with from Shahul.
Sure, sir. Thank you so much. We really enjoyed the session too, and it's really informative for us. So now I hope Sahul sir is with us too.
Yes.
Hello, sir.
Hello.
So, sir, I request you to like share up your screen and start up with the session so that
Okay. Yeah, okay. I hope you can all see my screen by now.
yes, sir, it's visible to us.
Okay. So, I did enjoy the last session from Sandip. It was a very cool session, and some things I was very interested in the recommendation engines and everything. It was a very cool and intuitive session. And now we will be going to very different one. This is something regarding NLP and a bit of ML, and I think we can start here. So at this session, I will cover about sentiment analysis in Python, and we will compare and see different approaches towards sentiment analysis using Python. So, yeah. So we'll start by introducing about telling about the task of sentiment analysis. Sentiment analysis is a kind of very common task in NLP industry right now because it is used in many applications like analyzing user sentiments, analyzing movie reviews, and the type of reviews the you put in every public forms like your food reviews, your Google reviews, and everything to analyze the sentiment and segment users into different classes. So sentiment analysis, when looked up from an NLP point of view, is essentially a multi-class text classification problem, because you have input text and you have a predetermined output number of classes to which you want to classify your text into. So mainly in sentiment analysis, we classify the text into three classes: positive, neutral, or negative. The user can increase or decrease the number of classes according to his or her application. Here, I mean, in general, sentiment analysis has three classes: positive, neutral, or negative. So this is about sentiment analysis, and this is the basic introduction and understanding you need to have to continue this session. So next, we will see different type of approaches towards sentiment analysis. We have basically two different approaches towards NLP sentiment analysis. The first one is rule-based sentiment analysis. So what do you mean by rule-based sentiment analysis? In rule-based sentiment analysis, we have a definite set of rules that is used to classify given text into different classes. For example, you can see this image which I have shared. You have these three sentences, and you can see that there are some words which have been marked here. For example, in the first sentence, my experience so far has been fantastic. The word fantastic has been identified as a positive sentiment, and the whole sentiment is regarded as positive. So this rule-based sentiment analysis has a definite corpus of words, and it has a predefined corpus where it has classified or assigned the value of positive, neutral, or negative to each of these words. And basically what it does is that it searches for these words and then goes on to find if the word is present in any of your the input sentence, and then classifies your input sentence into positive, neutral, or negative based on that sentiment. So there are very popular two libraries which uses this approach. The first one is TextBlock and the second one is Vader. So TextBlock, both of these belong to rule-based sentiment analysis. Means they both have a definite predefined library set, predefined lexicon set, which is used to classify the given sentence into corresponding classes. So the difference between while talking about this libraries, there is a small difference between the the formulas of both TextBlock and Vader. We will see that later on when we do the hands-on session. I have prepared a notebook for this, and you can practice the notebook your own. So basic approach is that we have a dictionary of lexicons, and each lexicon is assigned to a corresponding word polarity. For example, a word fantastic will be assigned a polarity of 1, and useless will be assigned a polarity of -1. So using this polarity, we calculate the sentiment of a given sentence. This approach is called the rule-based sentiment analysis. So moving on to the next approach, this is the second approach towards sentiment analysis. This approach is called the embedding-based sentiment analysis. Means that instead of rules, we use text embeddings to represent words, and we use these text embeddings to train a model and then get the kind of sentiment analysis. So what is text embeddings? Essentially, text embeddings is, we have this NLP text which we input to the machine learning model. But if you know anything about machine learning or in general regard to computers, you know that computers can only understand numbers. So computers cannot really understand the natural text which you input. So we need to convert this NLP, this natural text, to some kind of numbers so that computers can process and understand it. So in this sentiment embedding based method to represent text, we use a model. We use an approach such that the words which are similar will be represented in similar manner. For example, the word uh, king and queen, they are actually similar in a way, but they are actually opposite when it comes to syntactic meaning, king and queen. So they should have a kind of difference between them when represented in space. For example, we have words like fantastic and great. So these words are actually very similar in meaning. So the words which are very similar in meaning should be represented in such a way that their representation is actually very similar to each other. So this is the basic approach to embedding based approach, and this is how we represent text using the text embeddings text embeddings that we will discuss in the next slide. So there are many type of text embeddings available. There are the first one. There are kind of packages which we can use to represent text in such manner. These packages are some of the popular packages are Glove, Fast Text, and Universal Sentence Encoder, Birth, everything. These all embeddings are used to represent text in such a way that it creates better understanding of the text to the machine. So this is the basic understanding of text embeddings, and this embedding based sentiment analysis approach uses this embeddings to create a deep learning model out of it, and then output the sentiment according to the after training a model. So you can see that the first one is Flare. Flare is an open source package. You can check out Flare on GitHub. Flare is an open source package you can use to do the sentiment analysis. It is already trained using these embeddings, and it is trained on a corpus of movie reviews. So if you have any task regarding in the domain of movie reviews, you can just log on. You can just use Flare without any training, and it will give you satisfactory results. So, for example, if you have an application in a very different domain, for example, if you have an application of sentiment analysis in your company, like a very niche application, like analyzing reviews of flight reviews or anything, so you have to have a custom model that, because when these pre-trained models will be trained on a corpus, like in a domain specific corpus. For example, if a model is trained on a corpus using of movie reviews, the, this model will only generalize in movie reviews. So the other factor is that if you have any other applications, very niche applications, where you want to try a sentiment analysis model, you can go and represent the text using some very accurate, represent text using some embedding package, and then you can build a custom model which suits your niche application. So we'll just go through the Flare package first. Flare is kind of open source. Flare is an open source package which helps us to do the sentiment analysis without any pain of training or anything. So let's see that now. Just share my screen. Let me just change my screen. Okay. So this is the Flare package. So this is kind of one of the best packages to do sentiment analysis. So, and there are other Flare also supports other tasks like name identity recognition and everything. So it is very easy to do sentiment analysis with Flare. You can see that you can just import the Flare package. You can import the Flare package, and then you can just go on to do anything you like. This is they have provided an example of name identity recognition. You can use the similar. There will be examples in the same repository to do sentiment analysis. They have pre-trained. They have a pre-trained model which is trained on movie reviews data. So if you have any applications that is also trained using Fire embeddings, so if you have any applications which is very similar to this, I think you should try using Flare. So other thing is that if you have applications from very different domain, you can just go on to train your model using your the embedding you like. So next we will go on to see how to train a model, how to train a custom sentiment analysis model using universal sentence encoder. Okay. So again, as I said, we need to represent text here. So you have this input text like this, and each text is in the form of natural language. You have these texts. Your first task will be to do any kind of any kind of task with NLP. Your first task always will be to convert the input text into numbers. So, converting text into numbers, we use methods like embed. For converting text into representation, we use a method. We use the embedding method. So you can. This is a way. For the sake of simplicity, what I do is that I'm using a pre-trained embedding method from Google, which we can use using TensorFlow. This is called universal sentence encoder. So if you have any input text, for example, you can see that if you have any input sentence, you can just pass it to the embedding package, and the embedding package will automatically generate the corresponding vectors, so that similar sentences will be represented in similar using similar vectors. So this is this is for simplicity. I'm using this approach. You can try any other embedding methods like Glove, FastText, or even Flare embeddings, which we can download and try. And there is another vector, like very popular word to vector embedding. You can also try that. So let's just move on to the next slide, and we will see how to actually train our custom model. I request all of you to just log into this link. If you can see this link, I request all of you to just log on to this link, and you can get access to a notebook. So I will also log on to the same collab notebook. Just give me a second. We can copy the link, and then it will. Yeah, so I hope you have all received, you have all copied the link and got this. So if you haven't done that, I will just put it in this comments or something. So yeah, so this is a notebook which I have prepared for this talk, and you can use this in this notebook. What we do is that I have compiled different all these kind of packages here, and also have created a model using TensorFlow embeddings. So let's go on through each cell. So the first cell, you just need to run the first cell here, and it will ask for just need to run this thing, and it will ask for a it will pop up for and ask for a Kaggle credential, which you should have by now. It is very easy. If you don't have it, it is like just download it from Kaggle. Just go onto your Kaggle account, and then there you can see an option for generating the. There you can see an option for generating the credentials. So just need to go into that and download the credentials in the local notebook. While running the first cell, it will ask for the credentials, and you just need to upload the credentials, because here I am importing data from Kaggle directly into Colab. So that's why this credentials is required. So after that, we will just run our, we just import the TensorFlow and pandas, or pandas and TensorFlow and pandas. Then we will download the dataset from Kaggle. Here I'm using the tweet dataset from Kaggle, which has kind of 1.4 million tweets, and the sentiment associated with each tweet is given as a label. So here we are. I'm formulating it as a binary classification problem. The labels contains negative 0 for negative sentiment and 1 for positive sentiment. Yep, 0 for negative sentiment and 1 for positive sentiment. You can see that we have the data set in our Colab notebook right now. Then what we will do is that we need to convert all these text into embeddings. Means that we have to convert these text into numbers, so that our machine learning model can basically process the text. So I will use as I said, I will use the TensorFlow embeddings from Google. So it is very easy to download. You just need to write this code. It will download the embedding for you, and you can use it in your local machine, your Colab or your Kaggle, anywhere you can use it very easily. So you will just wait for it to download. It might take some time. Sure. Yeah, it's done. So you can see that I have an input sentence here. Just you can see that I have an input sentence here. The sentence is, hi Samuels, this is our project, and what I will do is that I'm trying to convert this. I will convert this into our embedding using TensorFlow. So you can see that after running the code, it has returned a list of 512 vectors. So I will just print the sheet for you. We can see that it has returned an array of 1 into 512 vectors. So this means that our input text has been converted into a vector of 1 cross 512 shape. So this is what the TensorFlow embedding does for us. So in the next sentence, in the next cell, what I do is that I convert all these tweets into into embeddings using the same package. So I iterate on. I mean, you can pass all these as list, and it will return an embedding vector of all the tweets. So this while running this, yeah, it's done. So this converts all the thing into this converts all the input words into embeddings, and then we will define a model. Next, we can define a model. We can define a very simple model here. So we know that our all the input text has been converted into 512 vector. So we will create an input of shape 512, and we will add a dense layer. And we will add a dense layer. We'll add another dense layer of 128. And a layer of 64, then a last layer of 1, which will be our output. So this will be a sigmoid layer, and we'll print a basic layer output here. So you can see that you have these layers, and then we can easily go on to train our model. So what we have is, for the input, we have the embedded tweets, which we have represented using TensorFlow embeddings, and we have the target, and we decide on a batch size and number of epoch, and we just train our model like that. And that's how we train it. It's done, and you can see that it has a validation accuracy of 77, and you can plot the accuracy also if you want. It's kind of overfitting, I think. So you can just change the learning rate, the epochs, and tune it yourself. I haven't tuned it because it's kind of a demo notebook only. So this is how you train a very simple sentiment analysis model using TensorFlow embeddings, and we can also try out other models. Here you can see that I have the text flow, which I discussed earlier. The first approach is the rule-based approach, and we can just go on to try text flow here. You can see that, and there is this text flow, and the text flow outputs the polarity and the one second. Yeah, the text flow outputs the polarity and the sentiment score. I have, I mean, what I have done is that I want. Here you go. So what I have done is that I have just used this. I don't know. Just need to run every cell. I just skipped some of the cells. Yep. Right. So what I've done is that I ran the whole text block through our dataset and calculated the accuracy score. So it gives only 55% accuracy with text block. And next we can go on through to install Vader package. You can see that it installs, and you can do the same with Vader, and we can check the accuracy again. Vader also gives the same accuracy because most of this, these kind of packages are almost, both of them has kind of same approach, but it differs in very little manner sometimes, and also the output of both of these is different. So, but I have converted it into suitable form that we can actually compare the predictions. So the next package is Flare, as I discussed, and you can go on to you can go on to install Flare and run it through our package. So I have done it. This is, it gives only 50% accuracy, as I said, because the thing is that Flare is trained on movie embeddings, and now we have movie data, and we have used a very different data from very different domain, which is Twitter. So it is failing to generalize here. So this is what we get using the pre-trained models, and when if we train our model for like some more epochs, we can surely get better. We'll train our model for a 10 epoch and see how much accuracy we will get. Seems like I'll have to run it also again. So what I did is that I changed the epochs to 10 and to in our custom model, and we can run our custom model for 10 epochs and see how much accuracy we get. So we should get, I have recorded an accuracy of like 66% or 70% in our tweets using the custom model, which is not tuned. So if you have, I think if you tune the model, you can improve the accuracy very much, and you can also try different embeddings, other embeddings like bold, vector, glove, and everything, which will surely improve the accuracy. So you can use this notebook as a reference and run it anytime you like. Change or anything, I will give the. You can use the same link to access the notebook anytime. So this is about sentiment analysis. I think we have discussed. I think we have discussed from a very we have started from a very beginner point of view, and we did kind of packages, like we went through all the packages like TextBlock, Vader, Flare, and how to build a custom package using TensorFlow. I mean, it's all very easy. This is a kind of beginner project we can we can do in NLP, and there are different very different domains where it's applied, and You can try in different data sets. All the data sets will be, where there are different data sets which are available in Kaggle, where you can try your sentiment analysis model and everything. So once again, let me share my screen. Okay. So this is a notebook link. You can just go on to get this notebook link, and you can run it for yourself. Just create a copy for yourself and run it as you like. And you can modify it, try to run it for border box, tune the LR or anything. It should get better if you can do it. And okay, so next thing what I would like to share is that I'm kind of in the process of building a custom sentiment analysis model for Twitter, which I have in this repo. You can just go on to log into this repo and see log into this repo and see the my model. You can I am in the process. It's in the process of development. So anyone, I mean, if anyone likes to contribute, just send me. I mean, just send a PR. I will review it and we'll see how it goes. So in this project, what I have done is that I have created a custom model for Twitter domain. So you can see that none of the packages we tried is performing well for the in the data set, because the data set is from Twitter domain. And so I thought it will be better if we create a package for custom package for Twitter domain, and this Twitter sentiment package addresses the issue by creating a kind of custom model using different embeddings, different global embedding, and just go on to check my project, and feel free to send a PR if you have any. I mean, if you have any ideas to improve the project, and it's in the process of active development, so everyone is welcome to uh, contribute in the project. So after finishing the project, I will also be writing an article about how to do this, how to do an end-to-end sentiment analysis project from like a very beginner point of view to building a web app using web app for sentiment analysis. So that's about sentiment analysis. Now I think we can move on to the second part of the session. Just keep all your questions with you and shoot it after this session. I will do a ask me anything session after this. Just shoot your questions after that, so that I can answer to all of your questions at one go. So the next thing in our agenda is about this Automl. So if you have ever, just keep on posting these questions and everything, and I will read them and answer them after the end of this session. So the next thing about in this session is about Automl packages. So if you have ever wondered about the future of machine learning, I feel it Automl packages has lot to do with it, because we can see that all of our applications in ML are getting kind of automated, because because it's difficult to build solutions in house. Many of the companies, organizations, many of the organizations are, I mean, choosing to do some built-in packages or auto machine learning packages. Like you have many AutoML packages. You have Google AutoML. You have the autopilot from AWS. You have other AutoML packages like H2O.ai and mljar open source. Mljar is an open source machine learning AutoML package, which I have been contributing for like the past 2 months. It's a very cool project, and if anyone likes to check out, just check that project out. It's a very cool and rising project in AutoML. Anyone who has any interest in contributing to open source can contribute and check out the project and see if you like to contribute or not. So the basic how to do, I mean, what is, I mean, the basic need of AutoML is like it to address to do machine learning for people who does not really code very much, because there are people who does not really know to code very much, but likes to do some applications in machine learning. So that there comes the application of Automl and packages like mljar. So it's very easy to do Automl using mljar. And you can see that we have done a binary classification with like 10 line of code, I think. Yeah. So this is how you do a binary classification using or mljar. You can just import the pandas and the Automl package. Just fit your desired training data. You don't need to worry about missing data. You don't need to worry about train or validation. You don't need to worry about the pre-processing steps. You just need to import your package, split into your training and test set, and just give your package to fit in Automl. Automl will take care of everything, including missing values, pre-processing, fitting different models, and finding which model works better for your data, and doing EDA and everything. So you can control all these through different parameters which are available in Automl. We can control the model behavior. You can control which all type of models do you like to try, like you like to try tree based model or linear models or anything. You can control all that through the different parameters which are present in Automl. Just check out the project. It's a very cool project. You can also, if you're interested in open source contributing to open source, just going to find an issue which works for you and just send a PR. I'll make sure that it gets reviewed. So that's about mljar-supervised. So I think also check my package. So again, if anyone like to contribute, just send a PR. If you like the package, just star it and keep it in watch. It will be useful for me. So that's about this session. So if you like to ask any questions, feel free to shoot. I will try and answer this in this session. So please continue with your, please shoot all your questions you have, please. Yep.
Sure, sir. Thank you so much, sir. It's like really informative and like I love the concept of the AutoML, which you have just introduced us. And also, there is a question from Shamik further for like, how do you deal with sarcasm word in the text, like in the
Yeah.
NLP concept?
Yeah, very interesting question, Shamit. So, sarcasm, this is kind of place where NLP still have challenges, because comparing to other other applications like computer vision or machine learning, NLP has its own challenges like sarcasm, understanding grammar, and everything. So this is the kind of place where NLP is still kind of need to improve well, because there are models that are trained to detect sarcasm. If you want, you can try. You can try some of the open source projects like that. But I feel that personally, this is a place where NLP need to still improve, because NLP seriously fails to understand such things as sarcasm. Hope I answered that question.
Yes.
So,
Thank you, sir. Another question. Yes, sir. You can be able to see the question on the screen.
please read, please.
So how do you deal with the text content like the talk is good, positive, or was the talk good with a question mark? So in the model, how will it will understand the meaning of question marks there?
So as said, if your the embeddings which you use has some representation for the question mark, this will represent the question mark in such a way that the machine can really understand the punctuation, the symbol. So the thing is that when representing words, in some packages does tokenize the word question mark symbol and word into different lexicons and represent them differently, like birth. So these advanced packages might have some representation for these symbols, so that the machine can really process and understand it. So that is what I feel for this question. So I think if you are really concerned about the same application, if the punctuations, the issue with punctuations, I think, I mean, if some of your like the small scale machines is not, I mean, small scale models is not really doing good with this, you can just do a pre-processing step that identifies this symbol and go with it. But advanced packages like birth should have a representation for this symbol. So next question, is there any other questions?
Yes, sir. One question I want to ask from my side, like you have introduced us with the AutoML, AutoML topic, and there I found it very like interactive, because there is one question like AutoML. I have heard somewhere in the recent article like AutoML is the next wave of machine learning. So from my end, I want to ask like how it is good for someone who, suppose I'm not that much good at the code part or code level, so how is it good for me to use the AutoML thing? And s- also there are some generic cloud vision API labels, and also there is AutoML custom labels, so how can you differ between them accordingly?
The first part, as you said, the thing is that on a user end, it's kind of easy to use Automl, but when it comes to custom applications in organizations, they will require custom models, because these Automl packages are built on a generalized basis and cannot, I mean, their applications and their features and their DB, all that will be very too I mean, will be too complex for a simple Automl package to handle as of now. So they are kind of Automl. People are kind of developing or trying to develop packages so robust that it can handle any kind of features and create new features, so that it can beat even human level domain knowledge. So on a user level, it is easy if you want to. I mean, if you don't want to code much, if you don't want to code much and do some machine learning, but the issue is that you cannot achieve state-of-the-art results with AutoML. You cannot expect to achieve state-of-the-art results with AutoML. Till now, AutoML has its own limitations. So if you want to go after a level, you'll have to code your thing from scratch and build your thing from scratch. If you want to have only a basic model, you are free to use AutoML. On the face of organizations, what happens is that small scale or mid scale organizations actually suffer very much to implement models and deploy them and they deployed them. So they go on to they go on to prefer these AutoML packages, because it takes a lot of overhead from them. So on an organization basis, that might be on a mid scale organization basis, that might be get some advantage to them. But on a user level, if you want to go after a basic, your AutoML, if you use your AutoML package, at the end, your accuracy or the metric evaluation metric will be like 50% to 70%, and if you use your custom model, it will be like 20% better. So like it will go on to up to like 90%, and you can still improve. So this is the difference. You always will have a burden while using AutoML in the performance level, and it gives the flexibility to handle code, do machine learning without code. On the other level, you can see that you'll have to do the thing from scratch, but it's very difficult to do things from scratch and then put it in production and everything. So the second part of the question, I didn't quite get it. Can you repeat it?
So like thank you sir for the like clearing the first part of the question. The other one is like there is a AutoML is like provided by the Google Cloud. So there is images of generic cloud vision API labels if we use it, and also if we want to compare like versus images of generic Google Cloud API labels versus AutoML custom labels. So how can you like define this accordingly if you want to differ between them?
Yep. For that, you'll have to compare them yourself by in your application by trying the stuff only. We cannot predict their output or I mean the behavior without actually trying it. So I think if you want to compare between those kind of packages and everything, you'll have to try it yourself on your application. You cannot really predict their behavior without trying it.
And so one more question from the audience and is, does MLJAR supports NLP problem or computer vision problems?
No. mljar only supports machine learning, classical machine learning problems as of now. It does only supervised machine learning problems in
Okay.
tabular data.
Okay, so okay. So it looks like we answered or we have all answered the questions. And is there anything else you would like to mention from your end to the community or to the audience?
Yeah, just feel free to contact me at any time for any help. You can see my, portfolio link here. So seems like there is one more question.
Yeah, so there is one more question. So it
Yeah, yes,
uh,
please.
he said that like he used Stanford name entity recognizer for his pre-processing, but sometimes it isn't that much useful, especially with Indian names. What other NER packages do you recommend to use?
You can you can try Spacey. It is good. You can try Flare, and there is a package in Google Cloud which you can try. It is the best package which I have seen, but you need to pay money for that. The free packages you can try Spacey and Flare. That's all. That's all that I know. I mean, I have searched for pre-trained packages. These are the three packages which I see, like the Spacey package, the Flare, and the Stanford NLP. If you are willing to pay money, you can also try package from Google Cloud. Okay.
Okay, sir. Thank you so much, sir. I hope there's no other question left from the audience side. If there will be some, I will share it with you so that you can answer them after the session. I will directly share them up. And thank you so much, sir, for again for like joining us. And I hope this session will be helpful and informative and also interactive for all of us. So as it was different from the other ones, like it's a hands-on session, and our speakers, both the speakers, just a minute. Yeah. So thank you so much. And this is the like we have come with the ending of our session. So in the upcoming for the upcoming event, we have our data catch-up, sixth data catch-up on 17th of October 2020 by Naman Bhayani, who is the deep learning engineer at Geo, and Ashish Pratap Singh, who is the software development engineer at Amazon, and also Chakshu Garg, who is the data scientist at Messenger AI. So the topic we will be discussing on that day will be deploying computer vision models in cloud and introduction to Spark for data science. So I hope we hope to see you again, all of you again the next time. And thank you for participating in today's session. Thank you so much, sir, Sandeep sir, and Sahul sir.
Right.
Thank
Thank
you
you.
guys for
Bye.
inviting. Appreciate it. Take care. Bye.
Thank you all. Thank you so much.